Now let's look at arrow pushing today. In arrow pushing, there are two types of arrows you would normally see. One is this one with double head. That is used when two electrons are being transferred or moved. Another one is with a single head when only one electron is being transferred or moved. Arrow pushing is a very important concept you will see in general as well as organic chemistry, and is used to form new reactions as well as new resonance structures. To better solidify this knowledge, let's look at some examples. The first example we are looking at today is a reaction example. The reaction is C22- plus 2H2O forms HCCH plus 2OH-. So it forms ethene and hydroxide. So the first step is always to form Lewis structures. So C22- contains 10 electrons, and when we go through the steps of forming Lewis structures, we form something like this. So each carbon has a triple bond with another carbon and a lone pair. And of course, when you actually look at the formal charges, each of the carbon will have a negative formal charge because it has 5 electrons around it. Now let's look at the reaction. So oxygen is very electronegative compared to hydrogen. So oxygen would love to be negative, or would love to have a negative formal charge. So what would happen is the two electrons will form a lone pair on oxygen, causing this to form, so causing hydroxide to form. And oxygen will have a negative formal charge because it has 7 electrons around it rather than 6. Now when we form this, we have H plus ion being formed. Now that H plus ion will be attacked by the lone pair on one of the carbon. So one of the lone pair on the carbon will attack the H plus ion. This forms something like this. This is still an intermediate step because we still have another H2O which will go through the same process. So this H2O will also go through the same process of oxygen getting a negative formal charge because it will take the 2 electrons. It will break the bond, it will take the 2 electrons, it will form a lone pair on oxygen, and that's why oxygen will have a negative formal charge. H plus is being formed, and that H plus will be attacked by the lone pairs, or by one of the lone pair on carbon. So the only lone pair will attack H plus. When these lone pairs attack H plus, they form a bond. And when we form a bond, we get something like this, which is ethene. And then of course, we have 2 hydroxide being formed. So that is the reaction example. The second example is about forming resonance structures of this gigantic molecule. There are many resonance structures, but they all follow the same idea of arrow pushing or electron movement. And of course, as these are resonance structures and not reactions, we don't break bonds. So let's look at some of them. So in resonance structures, electron movement is happening. So double bonds are being broken, and the 2 electrons in the double bond will form lone pairs. So let's start with this oxygen here. It has a double bond with the carbon. So those 2 electrons will form lone pairs on oxygen. This will cause this carbon to only have 3 bonds. Now carbon follows octet, so it has to have 4 bonds around it, or 8 electrons. So what will happen is the 2 electrons, or the double bond between these 2 carbons, will get switched to form a double bond between these 2 carbons. And in that case, this carbon will have 1, 2, 3, and 4 bonds around it, so that follows octet. So that is good. But then this carbon will only have 3 bonds around it. And in order to follow octet, what would happen is the oxygen over here, so this oxygen, the lone pairs on this oxygen will be used to form a double bond. Now we looked at the steps of forming a resonance structure. Let's actually form a resonance structure. So we said that the double bond forms a lone pair on this oxygen. So when we do that, we will have a lone pair and the double bond will not be present. Now oxygen has 1, 2, 3, 4, 5, 6, 7 electrons around it, and instead of 6, so the formal charge would be negative, and oxygen wants to be negative. This carbon only has 3 bonds around it, and according to our steps, the double bond between these 2 carbons will be transferred between these 2 carbons. So this will form a double bond. and we will not have a double bond here. Nice, okay. Now this carbon only has 3 bonds around it, and according to our steps, the lone pair on oxygen will form a double bond. When we do that, you'll have something like this. Oxygen over here is 1, 2, 3, 4, 5. 5 electrons around it rather than 6, so it has a positive formal charge. Now this is a bad structure because of course oxygen wants to be negative and it's positive, which is bad, but it still contributes to the overall structure. So it's still a resonance structure. So that is one structure. Now let's look at another structure. So the second resonance structure also follows the same footsteps of double bond being broken between carbon and oxygen, forming a lone pair. This causes this carbon to only have 3 bonds around it, or 6 electrons. So the double bond between these 2 carbons will be broken and will be transferred between these 2 carbons. So that would be here. That's the electron movement. Now this carbon only has 6 electrons around it, or only has 3 bonds. So what will happen is the bond between these 2 carbons will be broken, the double bond, and the electrons will be transferred between these 2 carbons, forming a double bond over there. So that's over there. Now this carbon only has 3 bonds around it. So what will happen is the lone pair on nitrogen will form a double bond between carbon and nitrogen. So that would be something like this. So that's a resonance structure. Now let's actually follow the footsteps and make the resonance structure, because that is the process. Now let's actually make the resonance structure. So we said that the double bond is being broken between carbon and oxygen over there, and a lone pair is being formed. So that would be something like this. And similar to our first resonance structure, this oxygen also has 7 electrons around it. So the formal charge on oxygen would be negative. This carbon only has 3 bonds, and according to our process, the double bond between these 2 are broken down and is formed between these 2. So there will be a double bond here, and of course this one would be broken down. So, yep. Now this carbon only has 3 bonds around it. So what will happen in that case is the double bond will be broken between these 2 carbons and will form between these 2. So that would be something like this. So this carbon only has 3 bonds around it, and it has to follow the octet. So what will happen is nitrogen will give up its lone pair and will form a double bond between carbon and nitrogen. This will cause, of course, a double bond to form, but nitrogen only has 4 electrons around it. And it still follows octet because it has 4 bonds, so 8 electrons. But nitrogen only has 4 actual electrons around it instead of 5. So the formal charge on nitrogen would be positive. Now this is another resonance structure. Again, this structure in the middle is the best structure because it doesn't have any formal charges. And first and last structure has formal charges on highly electronegative atoms, which is bad. But again, it's a resonance structure. It contributes to the overall real structure. Okay, that's all for today. Thank you very much.